Hello, welcome to the headquarters of the BerlinUnited at Home team. Today is a wonderful day. Please join us and you will see our work. Hello. So this is our autonomous electric wheelchair. It has two laser scanners, one in the front, one in the back, one Kinect sensor. It uses a canvas interface and it has two computers. One tiny computer with a low-level controller and another computer, big one, with a high-level controller. So this is our working environment. As you can see, it's a really dynamic environment. There is too many people working here, many of them working in an autonomous project. That's me in the upper right, and of course we are coordinated by Professor Raul Rojas. So this is the environment. As you can see, there are many people the whole day, really busy. Then a lot of doors, of course long corridors, some lighting with bulbs, and this power saving lighting after 30 seconds switches all the lights off. You have long corridors here to test our behaviors. Of course we have a kitchen, and in this kitchen we can perform some tasks. Then the very first thing we need is a map. Of course the robot is able to build its own map with its sensor, but we need a better representation with the exact location of furniture, of course doors, and with this model we build a polygonal representation that later is used to build a 3D representation to compare. And then this representation is loaded into our high-level planning module. Like here we choose a destination, then a path is calculated, and then begins the process of fine-tuning some parameters before using the real model or the real robot, in this case the autonomous wheelchair. As you can see here, there's a simulation with the same tool we use in real time to control the chair. You can see how it's adjusting its motions according to the desired path and the potential fields. Then we use it in a real world with the real chair. Here the chair is looking for the longest direction to move, and it doesn't know anything about its world. Like in this example, it's using only free-form navigation. When it finds some obstacles, it memorizes by a short period and reacts. Like in this example, it needs to decide between two possible directions, the left or the right. But finally, it decides going right because it's longer, and then it continues avoiding unexpected obstacles with these potential fields and the forces that we have already calculated. It avoids a corner, really good, and so on. We can continue until the end of the journey. Then, with all the data, including Kinect, we can build a 3D representation. That is more accurate map, that is more useful for this kind of purposes with localizing, of course, and well, it will be really nice to have this kind of maps of the environment in Robocup, like kitchen of an entire house. Then with the Kinect, we can also build these 3D models in the absence of light. That is really important for some applications in the real world. Hello again. Now we're going to see our particle filter localization algorithm running in the electric chair. In this example, Jan is driving the chair, and you can see the difference between our high-level planning map and this low-level sensor map. This is actually the map built with the sensors of the robot to plan. Here, for example, the chair is just able to see things at a height of about 10 centimeters height above the floor, and you can see it's performing real well. The chair is moving, and of course the exact location is being calculated, so it's performing really good. But we need this kind of map that of course we cannot recognize doors
or furniture, etc. Now, we can build more accurate 3D models by using a realized particle filter. In this kind of filter, every particle has its own hypothesis of the entire path that the chair has traveled. And in this way, we can build accurate 3D models. Many times we do that offline.
Hello, Robot.
Hello, I am Ellie, the autonomous wheelchair at your service.
Where are you?
I am in the start.
Okay, please follow me.
Please put in front of me and start walking. Okay, I've got you. Please start walking.
Now we have added the speech recognition and the speech synthesis to our chair. And, of course, you can see both models working. But for this task, like the follow me test, actually the robot doesn't need any information about the environment because it's able to follow a person in any unknown environment with the things that we have shown before. But it's really nice to see both models working in the absence of light, of course. That's a nice feature of our sensors, like Kinect or also the laser scanner, of course. And, well, the chair is able to navigate, avoid obstacles, and, of course, stop if something goes wrong.
Now the final step. We will remove our main computer, the main laptop, with the high-level control algorithm and planning. And we will put all that software in this tiny robot. Here we have installed our terminal. We're watching and then we will run it.
I stop. Hello world, BerlinUnited team salutes you. Repulsion set to 0. Step set to 0.1. I continue.
Okay, so it's ready. It's running here in this tiny robot, the high-level model, and the low-level model is still running in the tiny computer. Robot, follow me.
Please put in front of me and start walking. Okay, I've got you. Please start walking.
As you can see, here in this final example, you could see all the interaction, and you could imagine that the robot, Darwin, that is sitting on the chair, is actually the driver. It can have different behaviors, like speaking or maybe even walking or grasping things. Of course, we need an arm, but we have one. We will show it really soon. But it's really nice and really complex to try to combine different behaviors coming from different robots, into a single planning sequence, like in this example. Okay, so we can navigate with the robot. As I said before, we have a katana robotic arm. It's ready to be installed in the chair, and we're still working with it. Of course, we have a bigger arm, but it's really heavy. We don't think to have it in the chair.
So, that was our demonstration. I hope you liked it. Hope to see you in Robocup in the Netherlands. Thank you. Bye. So, that was our demonstration. I hope